What is projection of a vector or vector projection? Students, this is a very useful concept and you should have a proper understanding on vector projection, since this is not only useful in mathematics but we use this concept by solving many problems of physics. So let's have a brief discussion on vector projection. So let's start with the definition of vector projection. Here you can see the definition on the screen. Let's have a look at this. There is a directed line segment PQ in this xy coordinate plane which represents a vector, and P is the point of application or initial point and Q is the terminal point. Now we draw perpendiculars from P and Q to x-axis. These are perpendiculars and we denote the feet by P dash and Q dash respectively. Then this length P dash Q dash is said to be the projection of vector PQ along x-axis. Similarly, if we draw perpendiculars from P and Q on y-axis, say this is MN, then this length MN is said to be the projection of vector PQ along y-axis. So it is very easy to find the vector projections. Say this is our x-axis and the vector PQ makes an angle theta with the x-axis. So we can use trigonometry to find this length. This length is nothing but mod of PQ into cos theta. And this length is the vector projection of PQ along y-axis. So this length is mod PQ into sin theta. Thus you can find the vector projections. You just have to remember, if this is a directed line segment which represents a vector, then if it makes an angle theta with this axis, with the x-axis, then this vector projection is mod PQ cos theta and the perpendicular vector projection is mod PQ sin theta. Now we will understand the physical significance of vector projection. So vector projection is basically the effective part of a given vector along a given direction. Let's take an example to understand this. Say there is a particle which moves in this xy coordinate plane and it starts moving from the origin and reaches up to point A. Okay? So its displacement vector can be denoted by OM. Now this is the OM is the total displacement of this particle in this xy coordinate plane. But if we want to know how much did the particle move along x direction, then we have to calculate its vector projection. So we draw a perpendicular on x-axis. Now you can see that the particle moves from here to here. So effectively it moves this much length, say this is point P. So OT is the effective part of this vector OM along x direction, which is nothing but mod OM into cos theta, if this angle is theta. And similarly, if we want to know how much did the particle move along y direction, we'll say that this has moved mod OM sin theta along the y direction. Okay, so I hope with this discussion you have a clarity about the vector projections.